Have you ever wondered how your phone magically knows which photos have your friends in them? Or how a chess computer can beat a grandmaster? The secret isn't magic, it's artificial intelligence, or AI. And today, we're going to pull back the curtain and see exactly how AI learns. It's a lot more like how you and I learn than you might think. Imagine you're teaching a toddler what a cat is. You wouldn't give them a textbook definition, right? You'd show them pictures. This is a cat. This is also a cat. This furry thing with pointy ears? A cat. You might even point out a dog and say, "This is not a cat." Over time, the toddler's brain starts recognizing patterns. Pointy ears, whiskers, a long tail, a certain meow sound. That's essentially the core idea behind how most AI learns. It's all about data and patterns. This process in the AI world is called machine learning. Instead of showing pictures to a toddler, we feed massive amounts of data to a computer program. We're talking millions of cat photos. The program, often called an algorithm, analyzes every single pixel in these images. It looks for common features, the digital equivalent of pointy ears and whiskers. We give it labeled data, meaning each photo is already tagged cat or not a cat. This is called supervised learning because we're supervising the AI, guiding it toward the right answer, much like a teacher with a student. With every photo it processes, the AI makes a guess. Based on the patterns I've seen, I think this is a cat. If it's right, its internal model is reinforced. If it's wrong, say it mistakes a raccoon for a cat, it gets corrected. This correction is crucial. The algorithm adjusts its internal calculations, its understanding of what makes a cat. It might learn that while raccoons also have fur and pointy ears, their facial markings and ringed tails are different. This continuous cycle of guessing, getting feedback, and adjusting is how the AI gets smarter and more accurate over time. It's a digital trial and error process on a colossal scale. Now let's get a little more technical and talk about the brain of the AI. This is often a neural network. The name sounds complex, but the concept is inspired by our own brains. A neural network is made of layers of interconnected neurons, which are just small computational units. When we feed it a cat photo, the input layer of neurons activates. Each neuron processes a tiny piece of the image and passes its signal on to the next layer. As the information flows through these hidden layers, the network starts combining simple features into more complex ones. The first layer might detect edges and colors. The next might combine those edges to recognize shapes like ears or eyes. A deeper layer might piece those shapes together to identify a cat's face. Finally, the output layer gives the probability. I'm 98% confident this is a cat. This layered approach, known as deep learning, is what allows AI to understand incredibly complex patterns, far beyond just identifying cats. It's how AI can analyze medical scans to detect diseases, understand the nuances of human language for translation apps, or even compose music that sounds like it was written by Bach. The deep part just means there are many layers in the neural network, allowing for a very sophisticated level of pattern recognition. But what happens when we don't have neatly labeled data? What if we just have a giant, messy pile of information and we want the AI to find patterns on its own? This is where unsupervised learning comes in. Imagine giving a computer millions of customer purchase histories without any labels. The AI can sift through this data and start clustering customers into groups. It might find a group that buys coffee and books, another that buys electronics and video games, and a third that buys gardening supplies. It doesn't know what to call these groups, but it recognizes they are distinct. This is incredibly useful for things like market segmentation, or finding anomalies in financial transactions that could signal fraud. The AI is like a detective, finding hidden connections without being told what to look for. There's one more exciting way AI learns, and it's my personal favorite: reinforcement learning. This is the secret behind AI that can play games like Go or master complex robotic tasks. Think about training a dog. When it sits on command, you give it a treat, a positive reward. When it chews on the furniture, you say, no. A negative consequence. Reinforcement learning works the same way. The AI, or agent, is placed in an environment like a video game. It starts by taking random actions. When it does something good, like scoring a point, it gets a numerical reward. When it does something bad, like crashing, it gets a penalty. The AI's only goal is to maximize its total reward. It doesn't know the rules of the game. It just knows that some actions lead to rewards and others lead to penalties. Through millions of attempts, it learns a strategy, a policy, that maps the best action to take in any given situation to get the most points. It's not just memorizing moves, it's learning to think strategically. This is how AlphaGo, a Google AI, was able to defeat the world's best Go player, by discovering strategies that human players had never even considered in the thousands of years the game has been played. So to recap, AI learns in several key ways. In supervised learning, it learns from labeled examples, like a student with a teacher. In unsupervised learning, it finds hidden patterns in unlabeled data, like a detective. And in reinforcement learning, it learns through trial and error, by receiving rewards and penalties, like an agent learning to master a game. Each method has its own strengths and is used to power the different AI applications we see all around us. From the recommendation engine that suggests your next favorite show to the navigation app that finds the fastest route through traffic, to the scientific research that's accelerating discoveries in medicine and climate science, it all comes down to these fundamental learning processes. It's not a mysterious black box. It's a powerful tool built on the principles of data, patterns, and feedback. And the more we understand how it learns, the better we can shape its development to create a smarter, more helpful future for everyone. Thank you so much for joining us at LearnLab today. If you found this explanation helpful and want to dive deeper into other fascinating topics, don't forget to like this video and subscribe to our channel. Hit that notification bell so you won't miss our next adventure into the world of knowledge. Until next time, stay curious.